This week, we are talking all about area. Area. We talked a lot about it yesterday and what it is and how it's measured. So remember, friends, that area is the amount of space that is inside a closed two-dimensional figure. We were working a lot with rectangles yesterday, right? Those closed two-dimensional figures. The rectangle, of course, is that two-dimensional shape that has two long sides, right? And then we were talking about how we actually measure area. And we introduced the concept of square units. And so when we talk about square units, it can be a number of different measurement units, right? We introduced inches, feet, yards, centimeters, meters. It can be a number of different units of measurement, which of course we will be exploring later on in the year. The important piece, though, is to remember that when we calculate area, when we measure area, we're doing it in square units, whatever that unit of measurement is. And the questions that you read in math, most of the time, will identify the units of measurement. So it is important when we are answering a question about area, we are answering in the unit of measurement that's being introduced, whether it's square inches, square feet, square meters, square yards. But let us always pay attention to that detail, super important, that we would get from close reading. Yes? All right. So today we're going to keep on going with our exploration of area. And today you're going to be introduced to the concept of area in what we call a non-rectangular shape. That's a lot. That's a big word. Non-rectangular. So of course, what I mean by that, with that prefix of non, means not rectangular or not a rectangle, right? Again, let's break apart those words and use those unfamiliar word strategies. When we get stuck, we apply those strategies across every area of study. Again, non-rectangular, two-dimensional shapes. We're going to be exploring a little bit more. In a moment, I'm just going to share my screen so that we can quickly review what we did yesterday on pages 305, 306, before we go forward. Does that make sense to everyone? Perfect. So please, again, make sure you have page 305 in front of you. It's that one with the green on the top where you fill in what we generally do at the beginning of each lesson, right? Give me just one moment so that you can see it. So again, friends, yesterday when we were talking about page 305 and we were filling in this page in your groups, we were talking about what you knew about square units. So again, square units, in simple words, they're used to measure area. An illustration, a very simple one, right, is a rectangle that, of course, is being covered by 6 square units that you can see here, and I've identified just one square unit here. Examples of square units, again, can be many different types of units of measurement. Here, I gave you some examples: a centimeter, foot, an inch. Could be a number of different things. We could go into the metric system and talk about meters, for example, or kilometers, for example. And then we talked about non-examples. Non-examples. We were talking about lines and circles, right? And then on page 306, I wanted to take a slightly closer look at with you. Slightly closer look. So on Question 3 up at the top, it's saying to circle the rug below that you think shows the correct way to use square units to measure its area. So remember yesterday we saw a couple of examples, right? One was nice and beautiful and it covered all of the space inside the two-dimensional or flat shape. And then we saw one, there was a hot mess. It was just all over the place, right? So this, we just know, that's a no. This is definitely the rug that shows the correct way to use square units. Why? Because the squares fully cover the space we want to measure. They completely cover the rug without going past the edge. And remember, we talked to, super important, no gaps, no overlapping. No gaps, no overlapping. Now, it's asking, so what is the area? It's 10 square units. Why am I saying square units? I'm saying square units because in this particular rug, we don't have a unit of measure identified. So let's say it was inches. It would be 10 square inches. And we're going to be seeing that later on. Now, something for you to think slightly more deeply about, and we're going to be discussing this a little bit more in future lessons. Some of you will see here that this also looks like an array. It looks like an array that we would use to model a multiplication expression. So as we go further into our studies of area, you are going to see that we can apply what we call formulas to calculate area. You're seeing here that this is 10 square units. Why? Because if you take a look at this rug or this array, you are going to see that you have two groups or two rows of 5. What is that product? It is 10. More on that later, my friends. All right, let us take a look now at today's work. I am on page 307 right now. I'm on page 307. And on page 307, you are seeing some models here, rectangular shapes. So it's asking you to take a look at these problems. So it says to look at square A right here, square A to the right. It says to use an inch ruler to measure the length and width of the square unit next to square A. Do we need to get out the ruler and do that right now? No, we don't. I always have a ruler right here in case we need one. So it's going to say, what is the area of this square unit? It's asking you to measure this one over here. It's asking you to measure it. So if we take a ruler, and this is our ruler, right? Our ruler, and it's asking you to measure over here, you are going to see on the ruler that it is in fact an inch in length. It is an inch in length. So if you see here to here, on the ruler mark, it is showing that it is in fact an inch. So how are we measuring this? We are going to say that it is 1 square inch, right here, 1 square inch. So given that, it's going to say, so then what is the area of square A? If this is 1 square inch, and we have 1, 2, 3, 4, the area of this larger square, of course, is 4 square inches, because we have this 4 times. Okay? So let's take a look now at number 2. Let's take a look at number 2, and it says to look at this rectangle below. We're going to call it rectangle B. Rectangle B. And it says to use a centimeter ruler to measure the length and width of the square unit next to rectangle B. What is the area of this square unit? So friends, we are going from inches, which are those larger markers. Wait for it. Look what I do with my ruler. I simply do this. Bloop. I turn it around. Why? Because now the other side is centimeters. How many of you knew that? On one side of the ruler, we have inches. On the bloop, other side of the ruler, we have centimeters. That's pretty handy. It's asking us to measure that little square unit. So, okay, here we go. And oh, look at that. This little square unit to the side is in fact 1 square centimeter. It is 1 square centimeter. So, it is saying, what is the total area of rectangle B? Well, friends, can we all forward count by 1? I think we can. So if this is 1 square centimeter, well, what is going to be the area of this rectangle? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35. 35 square centimeters. 35 square centimeters. Students quickly see when they are calculating these models is that, again, it looks like an array and it has a certain number of rows, a certain number of columns. Students quickly recognize that they can forward count, right? So we could forward count 7, 14, 21, 28, 35, instead of counting every single square. Students also see later on that they can build a multiplication expression instead of forward counting. So they can see that they have 5 rows of 7, which also equals 35. Again, more on that later. All right, let's take a look at this little discuss green bubble over here. It's asking us, how did you find the area of each shape? So of course we counted. We first measured and then we counted. And so it's also giving you something to think about. Would it take more time here to deal with square centimeters or square inches? So you can very easily see here that centimeters are smaller. Is it going to take more time to count centimeters than inches? Of course, because centimeters are so much smaller. All right. Now, friends, let us take a look at page 308. 308. And it looks like this. It looks like this. So here's that super long word again that we call non-rectangular shapes. Shapes that aren't rectangles. Are we able to find area for non-rectangular shapes? Of course we can. Is covering and counting that same model, does it apply here? It absolutely does. It's asking us to number and count the square units to find the area of each of these shapes. The first one in number 3 is started for us. How convenient. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So the area is, of course, 10 square units. 10 square units. Can we do this also in number 4? Of course we can. Here we go. 1, 2, 3, 4, 5, 6, 7, 8, and 9. So of course this area of this non-rectangular shape is 9 square units. When we take a look at number 5 down at the bottom here, it's saying, how is finding the area of a rectangular shape like finding the area of a non-rectangular shape? How is it the same? Well, friends, because we count. The area of both shapes can be found by counting the square units that cover the shape. And in number 6, it is saying, explain how to find the area of the rectangle, and then find the area. So friends, here you can see that the rectangle is already covered. It's already covered with the square units. So all you need to do is count them. You just need to count those squares. And there are 12 total, friends. There are 12 total. Please make sure you are taking really good notes here. So again, the shape is already covered with square units. So all I need to do is count the squares. The area, after counting, of course, is 12 square units. You could also simply label, as we did on the prior shapes. You could say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. In your brain, could you skip count by 6? Yes, you could. You could say 6, 12. Could you, in your brain, do a multiplication expression and say you have 2 groups of 6? Yes, you could. Okay? Again, friends, we are looking at area of rectangular and non-rectangular shapes. Okay?